Hello there. Today we'll be doing 3 ways to split strings with equal ones. So we're given a binary string of this particular length with ones and zeros, and we want to split into like 3 parts where each part has the equal number of ones. As you can see in the output, there are 3 ways to do this. So how many ways is there to split 5 ones? Well, there are no ways to split that, or 4 ones. Well, anytime if we have a number of ones um, is modulus 3 does not equal 0, it's impossible to split, and we can return 0 immediately. So let's count the number of ones and do that modulus system. So let's say if ones, so not for I and ones, let's get the indexes of all ones. So let's say one's index is equal to for I in range lang of s if s of I is equal to 1, we're going to insert that I into our one's index. And let's say what num1s is equal to length of one's index, and that's how we get number of ones. Run. Oh, no, that's not what we want. Let's just take away a 1 here and then run it. Perfect. Okay, so next thing we need to do is else if, let's say num1s is equal to 0. Let's say there are 0 ones. What happens then? That means that we can combine, let's say there are at least 3 items. That means we can combine these 3 items in, well, I think one way, because we can split this only 3 items in 3 ways. But let's say we have 4 items. There are how many ways to do this? 2 ways, I think. Let's see. Turn 2, run. No, it's 3. So there are 3 ways to do this. Yeah. Oh, what happened? So what happens if there are 5 zeros? Is it 4? It's 6. Let's see. What's going on is that it looks like we could split this up into 6 ways. What does that mean? Let's say we split up this like this. Let's say we split it up like this. Let's say we split it up like this. Yeah. So we could split it up anywhere between these bars, and there are 2 ways to split it. Like we could split it up like this, right? So there are many ways we can split this up. Could we split it up like this? Yeah, I think so. Could we split it up like this? Yeah. Could we split it up like this? Why not? So why would it be 6 ways? because this is 1, 2, 3, 4, 5, 6, 7 ways already. Like, oh. Now that's 6 zeros. All right, let's try again. 10 ways? Wow. So for every 0, there are 2 ways that we can choose. And this is 5 items, choose 2, a combination. So what that means is that we have 5 over 1 and then 4 over 2. So that means we're going to return n mod n minus 1, because we only have 5 items. 1, 2, 3, 4, 5 times n minus 2. And we're going to divide this by 2. So this is basically 5 minus 1 is 4. And 4 times 3 divided by 2. Let's see. What is n? Num1s? No. We'll be needing this. Run. All right. Last thing we need to do is that we need to make sure that we mod our answer. I think that should be fine, hopefully. All right, we're good. Okay. So again, let me reiterate. So we found that we had 5 combinations, and we had with 6 items, we had 5 combinations. So that's going to be 5. And this is going to be 4, which is 20 divided by 2. 5 choose 2. There are 5 items, and we can choose 2 ways to split them. So there again, it's going to be 0, 1, 2, 3, 4, 5, 6. And there are 5 ways. 1, 2, 3, 4, 5. And we get to pick 2 points at which we get to split this. So you will pick, this is 1, this is 2. We only get to pick 2 places where we can split them. And that's why it's going to be 5, choose 2. We could split it here. We could split it here. But there's only 2 ways we can only split these. We have 5 choices, and we can split two ways. And that's the combination that we have here. Okay. So once we're done with that, we're left with the last case. The last case is that we're gonna have to return like the items in between the ones, the zeros in between the ones. Of course, they're equal number of ones, and this is going to be, I think, 5 or 6. Let me return something. Return 7. So this is 1, 2, 3, 4, 5, 6. 6 zeros, and we're going to return a 7. And so that means number of zeros in between the ones is going to have one number. And let's say we have zeros here, and that's going to be our second number. So there are there's 1 0 here. That means that's multiplying going to be 2. I'm suggesting this is going to be 14. Run, which is correct. And then you add another 0, it's going to be 3. And then, you're going to have a 3 times 7, which is 21. So it's the same as before because we have these zeros here, and there are a number of ways to split these zeros between these two numbers is going to be the number of zeros plus 1. Or it's going to be this particular item of 1 minus this particular item of 1. And that will include the plus 1 for the extra 1 that's inside. So what we're going to do, we're going to return, we have 1's index of, let's say, 1/3 of the 1/3 is going to bring us here into this item because we're gonna skip the index. So we start at 0, 1, and then 2. That's gonna grab us the 1 ahead of our 1/3. So we'll just automatically grab it. So 1/3 is going to be num1s divided by 3, and then 2/3 is going to be 1/3, 2 times 1/3. By doing this, we can grab this 1 and subtract this 1 here, and that way we can grab all the zeros and the extra 1 that's and at that additional 1 there. So we're going to take 1/3 minus 1's index, 1/3 minus 1, and we're going to multiply this by 1's index of 2/3 minus 1 index, 2/3 minus 1, and we're going to mod this answer by mod. So we just have to get everything into brackets before we mod, otherwise we'll have incorrect answer. Let's run it. 1 index, 1's index. Submit. And that's it. That is a pretty clean answer, if I do say so myself. Right. It looks like there is no, well, there's one for loop here. Fun. Okay, so that's it. That's the problem. Another way we can do this is to count up to the 1/3. As we can see here, we can count from here all the way up into our third, or from our 1/3 of 1. So there are 6 ones here, and then 1/3 will be a second 1. And we can count up all the zeros up until the 1 place, and then we can add it that way. I can show you that way right now. It will be real quick. It won't be as clean, but I think it will be more clear what we're trying to do here. So let's just do it. So we're going to do for I in range length of s, and so I think enumerate will help here actually. Enumerate of s. Okay, so if c is equal to 1, then we can do a count plus equals 1. That we're counting the ones. So we're counting ones here, and once we get to 1/3, we're going to add a number of ways plus equals 1. And if count 2 ones is equal to 2/3 ways 2 plus equals 1. And then afterwards, we're just going to return the number of ways 1 times ways 2, and we're going to mod those by our mod. So it looks like we don't need the I. So let's just remove it. And run. Submit. Also an answer, but we used one extra loop, and that slowed us down a little bit. But those are the 2 ways we can solve the 3 ways a string split with equal ones. I hope you learned something today about combinations, how many ways we can combine separate zeros. And we also learned a little bit about looking at patterns with number of zeros between the two and multiplying the different ways to combine the splits, because we're only choosing one way to split these number of zeros. And that would be just the number of zeros and the ones there. And so then we can multiply those two together. And I hope you can find this useful in any of your interviews in the future, this pattern. Well, if you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.